Welcome back. Today we're going to be talking about solving two-step equations. Our content objective is students will be able to solve two-step equations and check their solutions. Language objective is students will be able to state the mathematical properties used when solving equations. Why am I learning this? Well, it's important for real-life problems like helping decide how much pet food to purchase. So first of all, let's go over some background knowledge. All you need to remember is we use inverse operations to do other operations. So some examples may be addition and subtraction, multiplication and division. All of these are examples of inverse operations. Now, another thing that we're going to be utilizing in today's lesson is the different properties of equality. Whatever you do to one side, you do to the other, whether it's the addition, whether it's subtraction, multiplication, or division. We will be utilizing these in attempts to isolate the variable. Okay, so today our focus is on two-step equations. So what is a two-step equation? It's kind of self-explanatory. It's basically an equation that requires two steps to find the solution. In the past, we've worked on a one-step equation, so now we're upping it up in difficulty and making it two steps now. So here we have 3x plus 1 equals 7. Let me show you real quick what that would look like with tile. Okay, so notice we have here 3x plus 1 equals 1, 2, 3, 4, 5, 6, 7. So what should I do? Well, I want to get rid of this positive 1. So how do I do that? Well, I'm going to have to add a zero pair by adding one negative here, which means I'm going to have to add one negative here. By doing that, you're going to find that these go away. Let me just put it up here so that you can see. Because a negative 1 and a positive 1 is 0, and positive 1 and negative 1 is 0, leaving me with 3x equals 1, 2, 3, 4, 5, 6. Now, what you're trying to do is figure out how many 1s would make up each x. So what you could do is give 1 to each x and see how much that would give you. So if you split it completely, you're going to find that each x equals, you named it, 2. So the answer is x equals 2. So let's go back to the lesson once I find it. Here we go. Okay, so now let me show you what the steps would look like. So the first thing I'm going to do, as always, like in the notes, I'm going to identify the variable. The very first thing I want to do is get rid of what we call the constant, because why? Constants are typically your plus 1, your minus 1, and they are the easiest to undo. So for those reasons, I'm going to go ahead and get rid of this plus 1. So I'm going to go ahead and subtract 1 from both sides. So this becomes 0. This is basically applying the additive inverse. Okay, so now that's going to leave me with 3x equals 6. Now, the next thing that I'm going to get rid of is my coefficient. My coefficient is basically the number right in front of x. It's the number being multiplied typically. So here it's being multiplied by x, so the inverse of that would be to divide by 3. So what's 3 divided by 3? That's going to be a 1. So that's going to leave me with x equals 2. So notice our answer is exactly the same as what we saw from the tiles. X was also 2. Okay, so when solving an equation like this, there is a hard way and there's an easy way. Okay, the hard way would be to undo multiplication and division first, and the easy way would be to undo addition or subtraction first. And let me show you what that's going to look like. So to undo multiplication or division first, what you're going to do here is understand, oh look, this means 3 times x. So I'm going to divide everything by 3 first. Well, what that creates is basically 3x over 3 plus 1/3 equals 7/3. Already you can see it's not the best. So you're going to be left with x plus 1/3 equals 7/3. And then you're going to have to isolate the variable by getting rid of the constant. This is plus 1/3. So I'm going to subtract 1/3 from both sides, leaving me with x equals 6/3, which does reduce to 2. Now I'm not saying this method is wrong. It's just, it might be a little bit more difficult in comparison to, I don't know, doing addition or subtraction first. So here is where my variable is, so my focus is on the left-hand side. I want to get rid of the constant first, and that's my +1, so I'm going to subtract 1 from both sides. This is going to create 0, that's utilizing the additive inverse. I'm going to get left with 3x equals 6. Now this means 3 times x. I'm trying to isolate x, so I'm going to divide both sides by 3, because dividing by 3 is the opposite of multiplying. 3 divided by 3 is 1. What's 1 times x? It's just x, so x equals 2. So you'll notice it looks a lot more simplified when you undo addition or subtraction versus doing multiplication and division first. Okay, so let's recall the different rules for transforming equations. Our goal is to always get the variable one side of the equation by itself, and you're going to hear me say it a lot. You want to isolate the variable. Number 2, whatever you do to one side, you must do to the other to keep your equation balanced. Number 3, to undo the operation, you got to perform its inverse operation, which is basically the opposite. The opposite of addition is subtraction. The opposite of multiplication and division is division, and vice versa. Okay, and last but not least, whatever you always show your steps. And this is a new addition to the step. It's not always, I'm sorry. It is generally the easiest to undo addition or subtraction first. And that's, you're going to hear me say, getting rid of the constant first. Okay, so let's take a look at number 1. Here, I'm going to identify my variable. Okay, so my focus right now is mainly on the left-hand side of the equation. So if I cover this side for a second, I'm going to look, okay, what should I get rid of? Should I get rid of the 2 times x, or should I get rid of the -5? Like I said earlier, it is easier to undo addition or subtraction. So we want to get rid of the constant first. This is -5, so the opposite of subtracting 5 would be to add 5 to both sides. Okay, -5 plus 5 is 0, so that's good. That's going to leave me with 2x equals 19 plus 5 is going to be 24. Now, I'm still trying to isolate that x. This means 2 times x. My focus is still on the left-hand side. The inverse of multiplying by 2 is going to be divide by 2. What's 2 divided by 2? It is 1. 1 times x is just x, so that's going to leave me with x equals 12. So that is going to be my answer. But kind of like in previous lessons, we always need to make sure we're checking our answers, okay? But before we do that, I actually want to do this one more time, and I want to go over not just the work, but the justification, and then last but not least, we can go ahead and check it. So I'm going to show it to you again. So we have our 2x minus 5 equals 19. I like to circle the variable first to know that my focus is on the left-hand side. We typically like to get rid of the constant first because that's undoing your addition or subtraction. It is typically easier. So here, since it's -5, I'm going to add 5 to both sides. Notice since I'm adding 5 to both sides, I am utilizing the addition property of equality. Now I'm completely shortening the words for right now because I don't want to write the whole thing, but that is utilizing the addition property of equality. By doing that, a -5 plus 5 is 0. That's going to leave me with 2x equals 24 because 19 plus 5 is 24. I'm still trying to isolate that x, so this does mean 2 times x. Well, to do the inverse of multiplication, that's going to be division. So instead of multiplying by 2, I'm going to divide both sides by a 2. 2 divided by 2 is 1, leaving me with x equals 24 divided by 2, which is 12. Now, I kind of got ahead of myself, but here, since I divided both sides by 2, I was utilizing the division property of equality. Okay, so again, I'm shortening the words right now, but hopefully you can hear that I'm saying the whole entire property. Now, last but not least, I need to check my work. So what I typically like to do is read the entire equation, but instead of saying the actual variable, I go ahead and I put a set of parentheses as a placeholder for my answer. So here I'm going to do 2 parentheses for x minus 5 equals 19. Now what I'm going to do is go ahead and plug in my answer. We did claim that x is 12, so we're going to go ahead and plug that in here. So first we're going to multiply. 2 times 12 is 24. 25 minus 5 is that 19. Well, 24 minus 5 is 19. So this is true. That means this is indeed a solution for x to make this a true statement. So I am positive that my answer is x equals 12. Let's try another example. First, I'm going to go ahead and write the problem for my work. Now I'm going to go ahead and identify the variable y, kind of just to get my focus on one side of the equation. Since the variable is on the left, my focus is on the left. You can even cover the 25, pretend it doesn't exist for right now. And I'm going to look to see, okay, is it going to be easier to get rid of this negative 8 that's being multiplied by x? Or would it be easier to get rid of this plus 1? Hopefully, you remember from previous examples, it is easier to undo addition or subtraction, which is to get rid of your constant first. So the inverse of adding 1 would be to subtract 1 from both sides. Okay, since we are subtracting, this is the subtraction property of equality. So for that, that's going to leave me with negative 8x. Positive 1 minus 1 is 0, because I was using the additive inverse property. 25 minus 1 is 24. Now my variable is still not isolated yet, so I need to get rid of this negative 8. This does mean negative 8 times x, so I want to do the inverse. What's the inverse of negative 8 times x? Well, since it's multiplying, the inverse would be to divide. Now, before I actually do that, I do want to talk about something. Some students automatically think this is a minus 8, so they get tempted to put plus 8 to both sides. You need to think about what relation this number has with x. And you'll notice it's not subtracting 8 from x, it's actually being multiplied. That's why we are going to be dividing, because the inverse of multiplying is dividing. So since we're dividing both sides, we are utilizing the division property of equality. Let me go ahead and write it out for you so you can kind of see what it looks like. Okay, negative 8 divided by negative 8 is 1. 1 times x is x. Here, 24 divided by negative 8 is a negative 3. But before we claim that this is our final answer, we're going to go ahead and check our work. So I'm going to go ahead and rewrite the entire equation, replacing x with a set of parentheses. So we're going to put negative 8 times the parentheses plus 1 equals 25. Now what I'm going to do is go ahead and put in my answer of negative 3 in for my variable of x and see what that gives me. Negative 8 times negative 3 is 24, and it is positive because a negative times a negative is positive. If I add 1, does this equal 25? Yes, it does. So I'm confident that my answer is indeed negative 3. Because I know for a fact if I plug this in, it will create a true statement. Okay, now let's take a look at number 3. Okay, number 3 looks a little intimidating, but I'm going to go ahead and do the same thing that I've done in the last few examples. I'm going to identify the variable, so I'm noticing my focus is going to be on the left-hand side. It's still the easiest to get rid of the constant because it's going to be you either adding or subtracting. So here, since this is a positive 15, the inverse of that would be to subtract 15 from both sides. If you're wondering how that works, you could utilize the commutative property and switch it to say x plus 3 plus, x over 3 plus 15, because then you say, oh look, the inverse of adding 15 is subtracting 15. So if that helps. So here we are utilizing the subtraction property of equality, since we are subtracting to both sides. So 15 minus 15 is 0, leaving me with x over 3 equals. Here, are there more negatives or more positives? Hopefully you see that are more negatives. 9 to be exact. So now I am not done. I know this looks different, but if we keep going, you're going to see what this is. This variable is still not isolated, so I'm going to see what relationship the number has with the variable. This is x divided by 3. Okay, since it's being divided by 3, the inverse of that would be to multiply by 3. I'm going to go ahead and put 3 over 1, and you're going to see why in a moment, why I chose to do it on this side. here so that you can see, oh look, the 3's cross cancel and 1 and x have nothing in common, leaving me with x over 1, which is just x. Now here, negative 9 times 3 is a negative 27. So my answer is x equals negative 27. But for 4, I forget, since I multiplied both sides by 3, I utilized the multiplication property of equality for this step here. Okay, now it's time to check our work. We're going to go ahead and rewrite the equation, but instead of x, I'm going to put a set of parentheses. Everything else stays exactly the same. Now what I'm going to do is fill in my negative 27 into the x value for my placeholder, so negative 27. Here we're going to be left with 15 plus, let's see, a negative 27 plus 3 is going to be not plus 3, sorry. A negative 27 divided by a positive 3 is a negative 9. Let's see, 15 plus negative 9, there's more positives. There's 6 more positives to be exact. 6 does equal 6. So I'm confident that the answer indeed is x equals negative 27. Why? Because I know if I plug it in, it will create a true statement. Okay. So now, last example for me, and then I'm going to have you try some by yourself. Number 4. So first things first, we're going to identify the variable. It is on the left-hand side, so I have a choice between getting rid of divided by 5 or the minus 4. Hopefully you understand by this point, it's the easiest thing to get rid of the constant first typically because you're undoing addition or subtraction. Since this is minus 4, the inverse would be to add 4 to both sides. Of course, that's using the addition property of equality. Okay, so let's see what we have. We're going to have x over 5. Negative 4 plus 4 is 0. That was utilizing the additive inverse property. And here 3 plus 4 is 7. Okay, so my variable is not isolated yet. So again, I need to see what relationship it has with the number. So this is x over 5, but I highly suggest you read it as x divided by 5. Why? Because then you can understand if it's being divided by 5 and I want to get rid of it, I need to do the inverse. The inverse of dividing by 5 would be to multiply by 5. So I'm going to go ahead and put 5 over 1 on that side and put times 5 on this side. Why did I put it over 1? So I can see that they cross cancel, leaving me with x over 1, which is just x. And then on this side, 7 times 5 is 35. I always forget the very last step here. We did multiply both sides by 5, so we utilize the multiplication property of equality. Okay, now we need to check our work, so let's go ahead and replace x with a set of parentheses. Everything else stays exactly the same. Now that we have that, we're going to go ahead and place our 35 into the placeholder, which is right here. So I'm going to go ahead and put 35 inside. 35 divided by 5 is 7. 7 minus 4 equals 3. Is this true? Well, 7 minus 4 is 3, so 3 does equal 3. So I'm confident that x equals 35. Meaning if I plug in a 35 in for x, this does leave me with a true statement. Okay, so let's see how well we did. First, you identify the variable, so our focus is on the left. Is it easier to get rid of the 10 or the 3 times x? Constant first, so since this is a 10, we're going to subtract 10 from both sides, leaving me with a positive 3x equals 30. Our variable is still not isolated. This means 3 times x. So the inverse would be to divide both sides by 3. 3 divided by 3 is 1. 1 times x is x, so that leaves me with x equals 30 over 3, which is 10. Now, justifying, we subtracted 10 from both sides, so that was utilizing the subtraction property of equality. And then on this side, we divided both sides by 3, so we utilized the division property of equality. Okay, now we need to check our work, so we're going to go ahead and put 10 plus 3 times the value for x equals 40. I'm going to go ahead and plug my value for x, which is a 10. Now I'm going to simplify. We have 10 plus 3 times 10, which is 30. Does this equal 40? Yes, it does. So I'm going to be confident that the value for x is 10. So hopefully you got that right. If not, please feel free to rewind and watch the video once more to see where you made a mistake and fix it from there. Okay, now we're going to increase the difficulty level. So now pause the video and try number 6 by yourself. Okay, so for number 6, hopefully you identify the variable. It is on the left-hand side, so that's where our focus is. We should get rid of the constant first. So since it's technically a -6, -6, however you want to think of it, the inverse would be to add 6 to both sides. That's going to create a 0, leaving me with x over 7 equals, here there are more positives. How many more positives? There's 4. We're not quite done yet. We're still trying to isolate x. This means x divided by 7. So the inverse of dividing by 7 would be to multiply by 7. Again, you're going to see me put 7 over 1 on this side, but on this side, I'll just put 7. Why? So here you can see that the 7's cross cancel, leaving me with x over 1, which is just x. 4 times 7 is 28. Now to justify each of my steps, I added 6 to both sides. So that's using the addition property of equality. And then here, since I multiplied both sides by 7, I was utilizing the multiplication property of equality. And last but not least, we need to check that our answer is indeed correct. So I'm going to go ahead and copy it exactly the way that it is. So I'm going to put a placeholder for x for my solution. Okay, so now I'm going to go ahead and plug in my value of 28 in for my solution for x to see if that checks out. So -6 plus 28 divided by 7 is a 4. Does this equal -2? Well, here there are more negatives. How many more negatives are there? 2. So -2, does that equal -2? The answer is yes, so I'm very confident that the solution is x equals 28. Okay, so now at this point, we have just 2 more. I'm going to have you pause the video and try number 7 by yourself. Okay, so for number 7, here's what we're going to do. We're going to circle the variable. Notice that our focus is going to be on the left-hand side. We're going to get rid of the constant first, so we're going to get rid of this -7. So let's go ahead and add a 7 to both sides. This is going to leave me with -4w equals 22 plus 7 is 29. I'm going to go ahead and now still trying to isolate that variable. This means -4 times w. The inverse would be to divide, because that's the opposite of multiplication. -4 divided by -4 is just 1. 1 times w is w. Here the negatives don't cancel each other out, so it's going to stay negative, 29/4. So that's our answer. Now, to justify each and every step, we added 7 to both sides, so I used the addition property of equality. Okay, now here I divided both sides by -4, so I was utilizing the division property of equality. And then last but not least, we need to check our work to see if it checks out. We're going to do the same as before. We're going to write the entire expression, except instead of a variable, we put a placeholder for our solution. And now let's go ahead and plug in our answer. We have 29/4. Let's see if that checks out. 29/4. So here I'm just going to go ahead and put this over 1 so we can see that the 4's cross cancel. A negative, be very careful with that, times 29 is a -29. We're going to -7 equals 22. Is this right? The answer is no, because if you add the opposite, you'd be left with -36 equals 22. This is not correct. Were you able to find my mistake? Hopefully you did. Hopefully you notice right here, a positive 29 divided by a -4 is supposed to be negative. So let's try that one more time, but instead of putting a positive, let's put in a negative to see if it actually works. So we had for something for W minus 7 equals 22. So if I go ahead and I put in my negative 29 over 4, I'm going to go ahead and put this over 1. The 4's cross cancel, leaving me with a positive 29. Why? A negative times a negative is a positive. So we have 29 minus 7 equals 22. 29 minus 7 is 22. Is this true? The answer is yes. So that's something that a lot of students do. They have an answer, they claim to check it, and even though it's not true, they'll just, because they don't want to restart, they'll say, yeah, it's true. 22 equals 22, even though it didn't, like in the previous mistake that I made. So it's so important that you follow your work, you do the math, and you honestly check to see if it does leave you with a true statement. If it does, you know your answer is right. If it doesn't, you know you did something wrong and there's no point in submitting it. You should probably go back and check your work. Okay, last but not least, let's try number 8. Okay, so here we're going to go ahead and isolate our variable. Here it's easier to get rid of the constant first, so I'm going to go ahead and get rid of this plus 9. I'm going to subtract 9 from both sides, leaving me with 7w equals 32. Now, we're still trying to isolate that variable. This does mean 7 times w, so the inverse would be to divide both sides by 7, leaving me with w equals 32/7. Now let's justify our steps. Since we subtracted from both sides, we were utilizing the subtraction property of equality. Let's go ahead and write it out here. And then here we divided both sides by 7, so we were utilizing the division property. I'm going to go ahead and write it out for you this time, of equality for that second step. Now, last but not least, we're going to check our work. So we're going to have 7 times a value for w plus 9 equals 41. I'm going to go ahead and plug in my answer of 32/7 in here as my solution. I'm going to go ahead and put this over 1. You can see that the 7's cross cancel, leaving me with 32. And it is positive because a positive times a positive is a positive. Plus 9 equals 41. Actually check to see if this works. 32 plus 9 is 41, so I am confident that the solution is w equals 32/7. And I know this is true because I checked it in, I substituted in for w to see if it leaves me with a true statement, and it did. So, with that said, we completed the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.